Hi Spring fans, welcome to another installment of Spring Tips. In this installment we're going to look at the reactor based Cloud Foundry Java client version 3.3 whatever. It's a minor release at that point, so 3.3x. This reactor based client is very interesting to me. It provides you the ability to talk to the Cloud Foundry API, which in turn lets you write programs that work with the Cloud Foundry API to do all sorts of things that Cloud Foundry can do. There's a lot of reasons why you might do this, right? The common reason is because you want to control or interact with the platform to manipulate all the things that it allows you to control programmatically, right? And one great reason or justification for this is when you read the continuous delivery book with Dave Farley and Jez Humble. The continuous delivery book talks about having one kind of tool, one tool for every environment, one application that it can deploy everything, right? So a lot of us will typically write that kind of code, and you can't see it, but I'm using giant dripping air quotes here. A lot of people will use that code, they'll write that code using bash, right? And bash isn't really all that flexible, and it can be slow, right? So if you're using the Cloud Foundry Java client with bash, that's certainly workable, but you lose the ability to test it. You lose the ability to interact with that code and to refactor it and to sort of scale it out. Bash becomes very hard to scale after a certain point, even with functions and so on. So bash is not going to get you very far, and you do need to use bash, right? As much as I wish it were otherwise, Cloud Foundry requires you to run some commands before you can do a CF push with a manifest, right? You might, for example, require that your application be bound to a MySQL instance or to a key value store or whatever your backing service is. There's no way to declaratively say in a manifest, I need Cloud Foundry to please create this instance of this backing service, and then in the same manifest stipulate that that backing service should be bound to the application. You can specify the latter bit. You can say that I have a backing service that's already been created out there somewhere by whoever knows what, and I want to bind this application to that, but you do have to create that application somewhere. So if nothing else, your CF push just became two commands. It's CF create service, and then you're specifying the service name and the instance type, or rather the plan type and then the instance name for that service, and then you're binding that to the application. And if you want to do anything more complicated, if you want to check the state, if you want to see if an application is already deployed, maybe you don't want to create the service if it's already created, for example. You want to avoid that. If you want to deploy service brokers, if you want to deploy custom routes, all of this gets to be a little painful with bash, right? So while I like bash, I don't believe we should spend as much. I don't believe we should spend a lot of time, especially associated with business logic that we care very much about, in bash. And so we want one kind of application, one kind of thing that we can use to deploy the same working software from every environment, right? Across every environment. This is one of the key tenets in continuous delivery. It's that everything that executes, everything that is required to recreate the state of your system should be version controlled, including the configuration and the sort of creation of the environments themselves. So when the book was written, that meant that perhaps the assets in a virtual machine were version controlled, or maybe even the virtual machine itself. These days, we don't need to go that far. We can assume, given a plain vanilla sort of Cloud Foundry installation, that we can take our application and the binary that was created by building the application and a Cloud Foundry manifest and whatever, and get to a reproducible result. But still, having that recipe go beyond the manifest is interesting, and we don't want to do it in bash. So this is one thing that's really nice about the Cloud Foundry Java client, is that you get the ability to really interact with the API, and you can use the compiler to guide you in what is correct and what is not correct. You get more feedback. The other thing is that if you're using the reactive API, if you're using the reactive Cloud Foundry Java client, it can do things, frankly, far more efficiently than the command line client can do. Remember, the command line client is written in procedurally correct Go language code. You are to issue one command after the other. So you issue the first command, and then the second, and then the third, and so on. And if there is any inefficiency in the first command, well, that's too bad, right? The second command will have to wait until the first one is done. There is no opportunity to take advantage, for example, of the idleness, so that things that are successive, or rather that could be made concurrent, are concurrent, right? There's no pipelining in effect. And so we have the ability to take advantage of that pipelining because the Cloud Foundry Java client is based on Project Reactive, which, as you no doubt at this point know, underpins Spring Framework 5's reactive story. In particular, it underpins the Spring WebFlux web runtime. So we want to take advantage of the efficiencies of building reactive code. And remember, a lot of what we're doing here when we deploy applications is I/O. So this is perfect for that, right? Reactor and reactive programming in general are ideal for I/O sensitive and I/O driven workloads. Another thing that I really like about using the Java client here, the reactive Cloud Foundry Java client, is that it does, in that sort of continuous delivery spirit, it does give us one recipe that we can use to deploy the application across different environments. And in a sense, it's an installer script, right? It's an install.exe, if you will. It's a program that we can use to deploy the application itself. That logic could actually be in the application itself. Imagine that you have logic in the code base itself that deploys itself. You can just say, you can point it at whatever cloud machinery you want and say deploy yourself. And who better to deploy the system than the software itself, right? This is very different from the old sort of COTS model where you have something off the shelf, and if it's a cloud-based thing, if it's a distributed system, then it gets very painful to figure out how to deploy it. This is actually going to deploy itself. All it needs is familiar footing, so it's a much more professional feel. And specifically, there's no chance of somebody downstream getting it wrong because they're going to just use the exact same install script or install program as you would. I saw a great talk by Kelsey Hightower, and he was talking about this idea. He was talking about what he called self-deploying applications, and he joked that Bash is the reason people leave IT, and I think he's got a great point there. And he talked about having commands in your application that would actually hoist your application onto a cloud platform. In his case, he was talking about Kubernetes, which is certainly an option as well, but I think it applies to just anything anything cloud-based that has an API, of course. And Cloud Foundry is a great option here because you don't need anything more than the binary of the code base itself in order for this to work. Whereas with Kubernetes, you need a container or something, right? So this is actually an ideal opportunity for us. So we're going to go ahead and demonstrate the reactive Cloud Foundry client, and we'll look at how it allows us to work with the API. Now, my friend Kennedy Bastani and I, we wrote a book called Cloud Native Java, and in that book we have integration tests, and those integration tests all are driven using the reactive API, right? The reactive Cloud Foundry Java client, right? The API allows us to the client allows us to sort of smoke test, end-to-end test our chapters, the examples in the chapters. So I think that experience has been very, very useful for us because we saw how to compose all these different things and how to deploy working applications, with confidence that we'd get the right result. And it was also faster. Like I said, because we're using the reactive API, we're able to go faster than we could if we had written the equivalent commands using the Cloud Foundry CF client and a bash script. It was actually much faster in some cases because we could take advantage of concurrency and so on. So let's take advantage of let's go ahead and go to start.spring.io. We'll build a new application. Here we're going to use Spring Boot 2.0 M7, and we're going to use some auto configuration for the Cloud Foundry Java client. Now this auto configuration hasn't yet found a steady home, right? This is actually a pull request that is outstanding right now. I think it's going to land in the Spring Cloud Foundry module as a sort of module inside that. It'll be an artifact inside of there, so you can just you'll be able to bring in Spring Cloud Finchley. This is probably where that would live, in Spring Cloud Finchley, which is the version of Spring Cloud that'll be based on Spring Boot 2.0, which itself will land in the first few months of 2018. So this will be in Spring Cloud Finchley, which will succeed Spring Boot 2.0. So we're talking about a few months away at least before this code is final. But I just think it's really interesting, so I really wanted to sort of show you a demo. So let's go ahead and bring in Spring Boot 2.0 M7. We'll use the reactive web support, and I'm going to bring in a Spring Cloud dependency, not because I actually need anything from Spring Cloud, but because I want the Maven dependencies and all that stuff. And we're still going to have to do a little bit of setup there, but that's okay. So we're going to open this up. and that should give us Spring Cloud Finchley M4, M5, right? So we'll open that up, and the first thing that we're going to need to do before we get too far down the path is to bring in the Spring Cloud dependencies for Cloud Foundry, right? Which because it's not part of the code base yet, sort of we have to. I have Maven Clean installed it locally, but you hopefully won't have this problem by the time you're doing this. So Spring Cloud Foundry dependencies. All right, 2.0 build snapshot, and we'll say that this is a POM, and we'll say that the scope is import. All right, so there's that Spring Cloud Foundry dependencies, and we'll need to bring in Spring Cloud Foundry commons, right? So commons, this is where the auto configuration lives at the moment. Like I said, that might change, right? This is a separate module that is nothing to do with the service registration and discovery support, as well as the other web filters that are in the Spring Cloud Foundry sort of module. This is a particular auto configuration for the Cloud Foundry client. So maybe a better artifact name is Spring Cloud Foundry client. It'll change, but it'll be obvious when you look at the documentation or the GitHub repository what all is happening. Okay, so we have that all there. That gives us an auto-configured Cloud Foundry Java client, and that auto-configuration is there's a lot of moving parts in the Cloud Foundry Java client. None of it is particularly hard. In fact, you can look at the Cloud Foundry Java client website, and you'll find an example configuration which shows you all the moving pieces. And but there are a lot of moving pieces, so it's just nice to have that automatically taken care of for us. The Cloud Foundry Java client gives us the ability to write applications, as I say, that interact with Cloud Foundry. And Cloud Foundry can do a lot of things. You can deploy applications. You can scale them. You can create custom routes for them. You can, create backing services. You can scale those if you want. You can change the plans. You can create service brokers, which are basically APIs that themselves mediate access to a backing service, something like a database or a message queue or a key value store or whatever. And you can install those dynamically, and those in turn can have dependent sort of backing services. You can push applications. You can interrogate the API. You can deploy custom route services. You can do all sorts of things, right? You can actually push container images if you want. You can do all sorts of things here, and not to mention the security aspects, right? I mean, there's some things that are really well done using the Cloud Foundry Java client that there is no equivalent or analogous sort of command in the CF client itself, so in the CF CLI client itself. So one thing that my friend Josh McKenty and I demonstrated when we did our Cloud Foundry live lessons video for Pearson was using the Cloud Foundry Java client to do something across all the applications in a particular organization or space. So suppose we wanted to go through all the applications that were deployed using the Java build pack, and we knew that the build pack has been updated and there's an important security vulnerability. So what I want to do is I want to force Cloud Foundry to restart the apps if they have the Java build pack or the .NET build pack or whatever. If they use the new build pack, if they get restarted and they're not pinned to a particular version of the build pack, then they'll get the latest build pack, which will have the security vulnerability patch. So we want that. That's an interesting thing to do, but there's no button for that. There's no restart just the Java apps for everything in the organization and space. So you can write that code fairly easily using the Cloud Foundry Java client. All right, so let's see demo. And let me make this font a little larger, my friends. Okay. We'll say make it 22. Very good. All right. So we're going to have a application runner, and this application runner is going to need. It's going to be the thing that actually holds our business logic. And again, there's no reason this has to be an application runner. This could be a REST API. You could have a REST endpoint, a Spring WebFlux REST endpoint. After all, this is the Spring WebFlux. This is using the reactive web support, not Spring MVC, but Spring WebFlux. And we've talked about that at numerous opportunities and numerous occasions in previous videos, so I encourage you to check those out. We could use REST endpoint, for example, to manipulate the deployment of this software. We could have a Spring Shell application. That's another really compelling option. Is in a previous video we looked at Spring Shell, and we looked at how it can be used to create easy to use shells that we can interact with dynamically. There's a REPL, you can script it, and so on. So imagine having a shell that was designed to allow people to deploy your application. You could specify custom parameters, you could interrogate the state of the system, run health checks, do whatever you want, right? You can do all sorts of things. And you could also just, like I say, use it sort of in a command, command style, where you just run it and it just does something instead of having the REPL. So this is just an application runner. We're just going to create our logic in there, and it's not the only way to go. All right. So first thing we want to do is we want to say that we have a jar, right? We're going to actually have to deploy a jar somewhere. So let's make sure that we have a jar. Let's say that this jar is described by a Spring Framework resource, right? This is our jar, our binary that we're going to deploy. So let's say jar.exists. The jar must exist, right? We want to fail the program if that's not true. Where does this jar come from? Well, we have to inject it naturally. So let's inject it as an artifact here. Let's see, it's going to be an artifact, jar artifact. There we go. That's what we're going to depend on. And I guess that brings us to the next point, which is, where do we get that jar? So let's run this code and see what happens. Obviously, it's going to fail. All right. Run. Okay, good. So we have no environment variable called jar artifact. So let's set that up here. And we'll set up the environment variables, and we'll create a new jar or a new environment variable. You should do this in your environment. This could be a command line argument. You could use Commons opts, Apache Commons opts, for example, to manage environment, to parameters. You could even use Spring property, configuration property POJOs, where you actually bind a property to a bean and then dereference that property in your command line, in this application runner. You could use all sorts of things here. If this were a shell, this would be something you'd specify with -- whatever jar. But in this case, let's just hard code it. So I'm going to say that there's going to be a jar on my desktop called hi.jar. Now I don't actually have that jar yet, so this will still fail. But at least we've specified in the environment variable, which is what we want. So let's go ahead and create that jar for now. Okay. So cd make dir app cd app touch hi.groovy emacs hi.groovy at rest controller greetings rest controller. All right. Def hi path variable string name. All right. Greetings. Greeting. Hello. Name. All right. Get mapping. Hi. Name. Question mark. All right. Good. Look at that. Save Spring jar hi. Groovy. Well, I suppose we should run it first. Let's just do that. I knew I made a mistake. Okay, let's fix it. Here we are. What do we do? We've got the closing bracket there. Spring run hi.groovy. Okay, looks okay. Localhost hi world. Okay, that seems to be okay. Spring tips. Very good. Good. So now, Spring jar. Oh, we want to create a property file as well. Application.properties. We'll say management.security.enabled equals false. Okay. Spring jar. And we want to have the actuator bits, don't we? So actuator emacs hi.groovy at grab Spring boot starter actuator. This will be a Cloud Foundry application after all. So Spring jar hi.jar. Java minus jar hi.jar. Let's see if that works. Good, that seems okay. env. All right, good. So now, copy hi.jar to the desktop. And that should match what our environment variable is expecting. Let's try this. Okay. Jar must exist. It does it not exist? Let's see. Home JLong desktop hi. There it is. Home JLong desktop hi. Jar artifact. Oh, it needs to be resolved using a file prefix there. Okay. Why is let's restart IntelliJ here. It's giving me no end of trouble. cd demo. We want idea. Pom.xml. All right. All right, so we have our application. Let's see if we can run this again. Do we still have our environment variable? That is the question. Of course not. So we call this the jar artifact, and it will be equal to home JLong desktop hi.jar. All right, and run that again. Okay. Okay. Run is Shift F10. So Shift function F10. All right. Okay, looks like it's happy. So now, what do we want to do? We want to deploy our application. Well, actually, before we deploy our application, we need to deploy the service. So, to do, right? Number one. Number one is deploy the p-MySQL backing service, right? So, what do I mean by this? Well, if you've ever used Cloud Foundry, you know that it has a great catalog. So, CF catalog, or marketplace rather. It has a service marketplace. And this marketplace changes from one cloud installation to another. Right now we're using Pivotal Web Services. This is the hosted multi-tenant sort of installation of Cloud Foundry that Pivotal itself maintains on public cloud infrastructure. And so we use, for our backing services, we use different cloud providers, software as a service providers. And these are all very good, very, very useful. If you're running on-premise, you might have services that your organization feels need to be there, so you've deployed them yourself. You might have the ones that come with Pivotal Cloud Foundry, which a lot of times are different than the ones you'll see hosted here. And if you're using a public cloud like Google or Microsoft, well, they have and maintain their own service brokers for things that are unique and value-adding in those different environments. So you can use Bigtable, for example, in Google Cloud. If you're running Pivotal Cloud Foundry on top of Google Cloud, you'll see a service broker that allows you to talk to those things. So here we've got a number of different services here. I want to use p-MySQL, for example. This is a good one. When you look at the catalog, you see that the one that has no asterisk, this is a single entry, right? This is the name of the service provider on the left. The different plans here, separated by commas. The one that has no asterisk is free. So all these service brokers, all these service providers have to have a free tier so you can try something out. A lot of them are all free, they just want you to use it, right? But you can see that there's asterisks by the ones that are not free. So it's up to you to make sure you can kind of consult with the service broker, the service provider, to figure out costs and so on. But a lot of them are free. Like I said, almost all of them, as far as I know, they should all be free, at least at one tier. All right, so we want to use pMySQL because why not? It's a simple MySQL database. Our application doesn't use MySQL, but this is neither here nor there. What we want to do is, let's suppose our little jar, our hideout jar, required MySQL, right? And we can't start it up without having a MySQL instance bound to the application. If we were to bind a MySQL instance to the application, what Cloud Foundry will do is it'll inject an environment variable into the running process that contains your Java code, in this case our Groovy Spring Boot app, and that environment variable contains the credentials required to talk to that MySQL instance. If the MySQL instance should ever fail or whatever, your platform, your service provider, will provide different environment variables that'll point you to a different instance where the same data hopefully is available. It's up to the cloud provider to maintain things like backups and so on, but the point is our code doesn't need to change. We just hydrate those credentials from the environment variable. That's one of the tenets of a 12-factor app, is that it's stateless, and we can point it to different services from in development, in Q&A, and staging, and production, and in multiple environments in production, right? If we move it from one container to another, one data center to another, it should just be a matter of changing out that environment variable. And that's what Cloud Foundry does for you, right? We maintain that management, that bookkeeping. We make sure that those environment variables point to things that you can actually use and that have been provisioned for you, and whose credentials have been made explicitly and exclusively for your application. So I want to create that backing service first of all. So let's do that. Let's say we want to create a service. So we're going to say we want to create a service if missing, if it's there, if it's not there, right? So if create service instance if missing, and what are we going to do? We're going to use a pMySQL, I guess we said. So p-MySQL, and we want to have a particular name. So let's call it, Spring Tips MySQL, and we want what do we want? I think we should get the free one, right? And we'll talk about how we specify that in a second. But let's say that we have this method that takes two strings. Okay, create service if missing. All right. So string is going to be the service name, and then the instance name, the one that we want, the logical name we want to give it, so that we can refer to it later on. All right. So we're gonna create a service instance if it's missing, and we have to do some pretty, we have to interrogate the state of the system to make that work. So let's see how we do this. First of all, I wanna look at the API. I need to work with the API, so we can inject that API here using the aforementioned auto-configured Cloud Foundry Java client. So I'm going to use the Cloud Foundry operations here. I'm going to call this operations. We'll inject that into the constructor of the application. Very good. And now I can put that upstairs. Here we go. Now we are going to say that we want to first figure out if the service already exists, right? So we say this .operations services, and I guess we can list the instances, and then we're going to filter, right? We're going to filter the instances. So we're going to say filter si, and we're going to say si.getName. So si.getName equals ignore case instance name, or sorry, yeah, instance name, right? So there's that. Now this will give us back a publisher that will have one to many. If we had just done list, it would have given us all of the service instances, but here we're filtering down to just the one that we want. Notice how easy that was. It kind of rolls right off the tongue, right? I said this .operations. I said I want to work with services, then I want to specifically look at all the listings of them, and then I want to filter it, right? If I had done this .operations applications, I would have gotten support there for working with applications, for managing organizations, for managing build packs. The advanced thing itself gives you SSH code. That's not too interesting. Network policies, dynamic network policies, routes, service administration, spaces themselves, stacks. Like, are you deploying your apps to Linux, Cloud Foundry Linux stem cells, or are you using Windows virtual machines? Windows containers, basically, in Windows Server 2016. All this stuff is described here and modeled by this API. But behind the scenes, it's talking to a REST API, right? So it's talking to a REST API, but we don't have to worry about that. We have this nice type-safe client that knows about all this stuff for us. So there's our publisher. That'll tell us if something exists, right? So existing. Now, what we want to do is we want to create the service, right? First, we want to create the service, but only if there are no existing ones. So we're going to say that we want to do existing dot switch if empty, right? So if this publisher comes back and it has no value, remember this is a reactive streams publisher. It's a object that will notify us whenever there's a new record. It'll notify us. That notification is called an it's going to emit an object, right? Well, in this case, it may not emit anything. If it emits nothing, then it's empty, and we have to sort of switch streams, basically, right? We can't continue processing. We can't chain anything after that because there's nothing that's going to happen. So we need to switch and use a different publisher instead to handle this request. So that's what we're going to do. So what we're going to do is switch to a crate, right? Let's switch to a crate there, and then we'll just return a single or empty, and this will be a result, right? So mono of service instance summary. So we need to have a crate call in there somewhere, and that crate is going to say this dot operations dot services dot list service offerings. And what we want to do is now we're looking at the catalog, right? Before we were looking at all the provisioned services that we already have in our account. Did I already create a instance of this service, and is it already given a logical name? If so, it would be called instance name. Now I'm looking at the catalog. In order to do that, I need to send a command, and this is where the Cloud Foundry Java client is kind of interesting. There's these heavy use of builders, and take it or leave it, but it is what we have to use here, and it's with such a big API that's so flexible. I think this actually gives you a, you can do everything you need to do. Is my point. There's nothing that's being hidden from you. So that's kind of nice. So I'm going to say look at the catalog, and then filter the results that come back. And remember, I'm giving a service offering, so I'm going to filter the service offerings, and I'm going to say if the label equals the service that we want to look at, service name. Then I want to take that resulting, right now we've got a publisher. If you looked at this, this is actually a publisher of data, right? This is a crate publisher. So it's a publisher of service offerings right now. And we want to actually filter that and turn that into something else. So this is where we call flat map. So I'm going to take the SO here, and we'll say in our flat map that we're going to get the service plans, right? So this service offering has service plans, which is a collection of service plans. So we're going to get the service plans, assign that to a variable here, plans, and in the plans we're going to visit the plans and see if any of them are free, right? So this is where we want to figure out how it's free. So we're going to say plans.stream.filter, and we're going to need a predicate which says basically service plan is free, right? Now this should be pluggable. I say this would be something that would be nice to have pluggable. So here we're going to say predicate service plan predicate, right? Service plan predicate. Here we'll say service plan predicate, and we want to find the first one that comes back. Any of them, really. There's only going to be one, or it's not. Any of them will work, but we want any of them, really, or first one, doesn't matter, I suppose. And if one comes back, great, that'll give us a stream containing the first record, right? Or actually, in this case, it'll give us an optional, right? So I don't want the optional. I need to actually get the value that's in there, or we need to throw an exception. Something is very wrong. So, or else throw, new runtime exception. So runtime exception, couldn't find a service called service name, right? So that's the okay, we want to assign that to a variable there, service plan. So there's our free service plan, free service instance that we want, So I'll say free, and what I want to do is I want to use that to create a service instance, right? So we're going to create a service instance. We're going to say this dot, say operations dot services dot create instance, and we're going to pass in a create service instance request. So create service instance request dot builder dot and then we're going to pass in the plan name, and the plan name of course is the free plan name. So there's our name up there, and we're going to pass in the service name, and that should be the service name up there, and we're going to pass in the service instance name, and that's going to be the instance name, and I think that'll be everything we need. So let's hit build. Now this will give us a request that we can pass in there. So it's a create service instance request. Great, pass that there. All right, so we've got now a bit of code here. We're going to create the service instance using the service, the services subgrouping of functionality in the operations and the Cloud Foundry operations API. Now, by the way, going back to that, the Cloud Foundry operations API is a kind of high-level thing. It has all the functionality, high-level functionality that you'd expect if you were using the CF CLI, and that functionality is nicely grouped into these sort of sub APIs, and they in turn have to compose lower-level primitives. There's actually something called a Cloud Foundry client, right? And the Cloud Foundry client is very low level. It provides more control. So if you can't find what you need in the Cloud Foundry operations, you might check the client, but the client doesn't always have what you want. For example, the work of actually pushing an application to the platform, which is to say deploying the application, is actually composed itself of many other smaller things, and all of that, all of those individual things are what you would find here in the client. The push operation itself, though, is actually here in the operations API. So, a lot of things are happening when you do a push. It's creating services, it's creating routes, it's pushing an application, it's doing all sorts of stuff that you can take for granted if you want to, but if you want to pick apart that particular logic, you can do so by digging into the client. All right. So we have we do need to provide that extra operator there. So we'll say service plan is free. Great. That's our provided value there. All right. So now we've got we're saying that we want to create a service, and then we're going to return this. Now the return value here isn't super useful, right? It's a what do we get if we assign this? It's a void, right? That's not exactly what we want. So what I want to do is I want to say that I want to find the existing service instance. Now I want to confirm that everything's been written just by reading the data again. So I'll then say then many existing, and of course that flips this up into a service instance summary as well. So create. So what we're gonna do is we're going to go through and create it and then return it by searching for it. We're going to write something to we're going to create a new service, and then we're going to look up that service and return a publisher that contains that service. And the actual logic is as follows. We're going to say look for it, if it's there, create it, and then whatever you do, take the flux that comes back. Right now you'd have a flux, right? This is the result of this is actually a flux. Well, we know that it's only going to be one object, so we just say take it and then turn it into a mono. And in the reactive world, in the reactor world, a mono is a publisher that produces 0 or 1 values. A flux is a publisher that produces 0 to n values, where n could be infinite, right? So we're saying that we want to return. We want to look for the existing record. If there is no existing record, then use this publisher, which will create a new one, and of course it'll conclude itself by returning, it'll look for the existing one, and then we turn the whole thing into a result, and we return it there. All right. So let's return that all, like so, and this implies that we need a publisher that takes that returns a service instance summary. So this is a mono of service instance summary. All right, there's our create service instance if missing. Now this is all one big publisher, right? This actually is all of these different things, all these different little flows and branches and all that, all combines into one big publisher that has multiple steps or stages that can be pipelined, right? The reactor engine can pipeline that for us. It can manage that for us. Now, of course, here, you know, create service. Here we have a publisher. Nothing is going to happen yet, right? Nothing is happening yet because we actually need to visit the data that comes back, and we need that. You know, the result of that is that we actually have to subscribe to it. Again, in the reactive world, a publisher doesn't activate. Nothing happens. If I were to run this code, nothing that we just wrote would activate. Nothing would actually execute until somebody calls subscribe on the publisher. So we're going to have one publisher, so we're just going to say subscribe here, and we're going to assume that the last thing that's emitted from the publisher is going to be just you know, a confirmation that we're done, right? So we're going to say x log.info, and we need a log here, so let's create a log. Log equals log factory dot get log get class. All right, and we're going to say info, your application has been deployed and bound to the service. Okay, we need the single quotes. It took milliseconds to deploy. All right, now we need to provide some string format parameters there, and in this case it's useful to extract this out. So this is the service name, all right, and there's the service instance name, and we'll pass this in. We're going to say your application is called what are we going to call this? Well, we need to give it a name, right? So we know that we're going to be deploying an application here soon, so let's call this string app name equals stapp, right, for Spring Tips app. So your application, okay, has been deployed and bound to the service called instance name, which we're going to rename to be service instance name, and we need to provide a duration, right? So let's actually start the clock ticking right before long start equals system.current time milliseconds, and that'll be system.current time milli minus start. So we'll see the duration delta here. Okay, so what does that give us? That gives us an error. We need to compile this for it to run. String.format, good. There we are. Okay, so there's our first publisher. We're gonna actually, you know, that'll do. It doesn't do much, right? What it's going to do is it's going to create the service if it doesn't exist. So let's go see if I've already got the service. Okay, CFS. All right, so I'm going to delete this CFD minus F CNJ MySQL. Whatever. Actually, I don't need to delete anything. I can though. Do I want that one? No, it's fine. CFS. We've got two services. CFD minus F CNJ HDA. Good. Let's get rid of that. And then we're going to delete the CNJ MySQL. Those are the two apps. I need the card DB for later for other reasons. But point is, right now I've only got one service and I have no apps. Okay. So now let's run this code. Let's see what happens. So we'll say we want it to run. Okay, so again, it's a web application. One thing that's interesting is that you have to understand this pipeline could process, it could run asynchronously, right? So this command line runner it may well finish long before this publisher is done working, which is why if you don't have something that like the WebFlux API or Spring MVC keeping a socket open and thus keeping the process running, you may think that this isn't working. It's asynchronous, right? There's no reason that this publisher has to execute its different stages on the main thread. It could and often will execute on other threads, and you can control that, of course, by saying I want to subscribe on to a particular scheduler. So scheduler dot elastic, or here's a elastic scheduler and with times alive and all that stuff, right? You can do all sorts of stuff here to control scheduling, but keep that in mind, right? The beginning of this, the beginning here is not, the end is not captured here. It's captured in the last stage in the pipeline, right? Okay, so that's certainly interesting in and of itself. Let's see if that worked. CFS, good. So there's Springtips MySQL that created. What happens if we run the code again? Right, we know that it's supposed to do the right thing. If it's already there, it should leave it alone. If it's not there, we should get the results. So there's that. Okay, so nothing has changed. It's fine. Okay, so now we want to deploy the application, right? I want to deploy the application, and then we want to deploy and then bind it, right? So let's actually deploy the application now. So we've got a publisher that creates the service instance if it's missing. Now I want to deploy the application, so we're going to say push application. And the application will take the app name, and how many replicas do we want? I guess we want 2 for now. Why not? And we'll pass in the jar. Do we want to start the application? Let's say we don't want to start it, right? We're going to push, but we don't want to start. So in Cloud Foundry, if you deploy an application, but you need things like the backing service, you want to bind it before you start the application. Otherwise, the application will start up and it'll look for a database or a message queue or whatever, and it's going to fail. So there's no point in starting it. We want to deploy the application, though, so that it has a logical name and so that we can refer to it and manipulate it, but we don't want to start it. So let's create that method called push. Okay, replicas, jar, start, or no start, right? So we want to not start it, I guess is the right way to say it. So we don't want to start it. That's true. Okay. So let's go back to this, and in the push, we're gonna actually push the application jar itself. So we're gonna say path equals. This is the Java NIO file library, of course. We're gonna say jar.getFile.toPath. Very good. And we'll add an exception here. Throws exception. Good. And then we want to say return. We want to say operations dot applications dot push, and we're going to push the application to the platform. And this application, is going to it's going to use the path that we've just created. So pth there. We're going to say no start. We're going to give it a instance count. So replicas rather. We're going to tell it that we want it to have a particular name, so we'll give it the app name there. And I think that'll be enough, thinking about it here. Okay, that's enough. So then, what do we want to do? We want to confirm that we got the data. We want to confirm that the application is done. So then we'll say operations dot applications dot get application request dot builder dot whatever dot name app name. All right, so what does that give us? If we assign this to a result, app details mono, all right? So there's our application details. So when we return that, that's actually when we return, or when we return here. All right. And looks like we have everything we need there. So if we think about what we've just done, we want to compose that, right? Again, this is all one big publishing pipeline. So we're going to actually say, first, create the service if it's missing, and then do the following, right? Process this publishing pipeline. And then we're going to subscribe to that, right? So see how clean that is? We're actually deploying. We're saying, first, create the service instance if it's missing. Then, after this is done, run this. And then, as this is producing values, subscribe. All right. Now, remember, we told it to not start it, so we actually need to restart it now, right? We need to start the application, but we actually also need to bind the service. So we push the application, but there is at the moment no indication that this application should be bound to the service. So we need to say then bind application to service instance, and the application name should be passed in first, and then the service name second. All right, so let's go here, create that method. All right, and here we're going to use the operations thing again. We're going to say return this dot operations dot what do we want? I guess we want services dot bind service instance request dot builder, and here we're going to use the service instance name, and application name, app name, and then, is that right? Then we need to confirm. So I guess we could, if we left it as is right now here at that point, we'd get a mono that's empty, right? It would complete, but we'd have to listen to it by looking at the do on terminate, for example, publisher. And I want to keep the processing going. So instead of terminating here with an empty void based mono, I want to actually switch again. So I'm just going to return a a Boolean true to confirm that everything is as we expect. The true is nice because if we don't have the true and we know something is wrong, it's also nice because that's a value that our publisher can emit, and that's actually what we want in order to be able to continue chaining this with other processing. So Boolean mono, we're going to return a mono of Boolean, right? All right. Return. There we are. Good. So there's our mono, and we can continue chaining. So bind service to application. So we're going to say push the application, then bind the service instance to the application. Then now we need to restart the service, right? So restart the application rather. So restart application, app name, and here this is pretty easy as well. So create that method. It's going to be a mono of Boolean just as before. All right, and we're going to say return operations dot applications dot restart application request builder dot name. This is the app name. So here we are, dot build, and then return mono dot just Boolean dot true. All right, same as before. So now we can chain that again. So we're going to say create the service if it's missing, then push the application, then bind the application to the service instance, then restart the application, and then finally, once we have in this case, this will be, the last true value we received once, right? We don't actually care, but that's what that's going to be. That's going to be the output emitted value from this stage in the pipeline, right? And so we can actually just call it X. In other languages like Scala, you can do underscore, for example. So X. We can't do that, but X is fine. All right. And I guess that's it. I guess that's kind of an interesting little flow. So let's go ahead and run this and see what we get. Okay. First of all, let's go ahead and CFA, CFS, CFDS minus F, ST MySQL. So we're going to delete that. All right. And now this should deploy the application. It should deploy 2 instances of the application. And remember what's going to happen. It's going to take that jar. It's going to take it it's going to push the application to the platform. But it's not going to start. The platform is going to see the incoming jar, and it's going to create a container out of that jar. It's going to lay down a file system that has everything that's needed to run that application, including in this case a JDK, a JVM. It's going to sort of inspect the incoming artifact, so it'll know that it's a Java application. It's a .jar. If we were to upload a .war, it would download Apache Tomcat, and if it were Ruby on Rails or .NET or whatever, it would do the right thing there as well, right? But in this case, it's a .jar. It's going to be just Java jar, so it's going to download a JDK. In this case, it's going to be JDK 8 or whatever the latest and greatest is supported by default on the hosted platform. And by the way, there is, I think, preliminary support for using Java 9 by overriding the build pack, and that is something that we could have specified here if we want to be very specific. Now, it's going to do all that for us. It's going to create a file system. it's going to turn that into a container, which it'll then start if we tell it to, and it'll provision it and deploy it across the cluster. So in this case, it took us 73 milliseconds, so 73 seconds and 73.6 seconds. If we look at this, you can see st_mysql is there. It's been bound to this app called stapp, cfa. That's the apps command. There's the app. If we go to st apps like that, hi spring tips. All right. So there's our deployed Cloud Foundry application. Now, what we have done here is we've automated something that you could do in 4 or 5 lines of Bash with just a mere 130 or so lines of Java code. Now, is this better? Well, we could disagree or agree. We can have a discussion about that, certainly. But the point is, this is more maintainable, right? You can look at this code, you can change it, you can do more interactive things with it. It's faster. You can also do much more complex things. You can arrange, for example, to have certain things happen. You can interrogate the state and store things in variables in a much more natural way than you might with Bash. You can build tools on this, right? There's no reason you couldn't build your whole continuous delivery pipeline and then program it, right? This is you're not moving infrastructure around. You're using APIs to create APIs. So this gives you a lot of power. Like I said, I like the idea of having a shippable Spring Shell based application. You can put it in your continuous delivery pipeline, right? And you can say -- replicas equals 5 or whatever, and then point it to the jar, and then it'll do the rest. It knows exactly what's required to make sure that this thing is running correctly, and it's a tried and true proven solution. And you can also use this in your smoke test, to make sure that your end-to-end pieces are up and running. This is a very simple example, but as you saw, the API has a lot of power. You can do everything you could do from the CF command line, and in some cases even more, right? Because you can get at the low-level APIs that are used in aggregate from the CF CLI. All right. Well, with that, thanks so much for watching, and we'll see you next time.